Hello everyone, welcome to WINFra BRIDGE. Now let's start the session.
Now, depth of water table. So the depth of water table, if the soil report does not state that there is a water table at the site, then you can give a higher depth so that it will not consider water table into the design. If you want it to consider water table depth also, so that it will give you a much safer design, you can give 0 mm. 0 mm will be at the NGL. 0 mm will be here. 0 mm will be in NGL itself. If you don't want to give depth of the, if you don't want to consider water depth also, then you can give a higher depth. I mean, you can go for around 5 meter or 10 meters. So it will not consider that. Now, 5 of soil, uh, you can either give this value or not. It depends. It's okay if you don't consider this value also. Let's give 32 here, 32 degrees. Minimum of contact area for service loads and ultimate load. So usually, if you don't want to, if there is any, if you can allow any tension coming on foundation, then you can give the values here. So if you allow 20% loss of contact, then you can give minimum contact area for service loads as 80%. If you don't want to consider any tension coming to the foundations, then you just give the minimum contact area as 100% here. The same can be given for ultimate loads. So let's give 80% here. You can set this as default value if you want to. So whenever you use this STAAD Foundation, it will automatically give you all these details without you changing anything. You just, if you give it as set default value, then it will give all these values every time you open STAAD Foundation. Now you go to footing geometry. The footing type will be of uniform thickness. If you want to give uniform thickness, you can give that, or you can go for sloped thickness also, where it will give you a slope. It will show a slope, and also it depends on you. Like now, I will give you. Now I will give uniform thickness here. Now design type will be either you can give a set of ranges for the sizes of the footing, and it will directly according to the loads coming on the columns, it will design and give you the sizes. Or if you want to have same foundation sizes, you can set the size and give that size so that it will check for that particular size itself. So if you want to calculate the dimension, you can give a range here. So there will be minimum width and minimum depth, length for it to start the iteration process. It will iterate the design. So if you give a minimum length and width and then thickness of the foundation, it will start the iteration from that point. And then if you give the maximum length and width, it will stop at that point. So, or you can set the dimension here where it will only ask you for that particular dimension. So I will show you the difference here. So let's change the design type as calculate dimension. I want to start the design from to 1.5 meters. So I'll give 1.5 meters here. Then minimum length will be and width will be 1.5. I want to start the minimum thickness of the foundation should be 500 mm. We are giving this input to STAAD Foundation so that it will start. It can start from some point. So the maximum width where it should stop the iteration process will be like I'll give 10 meters and then 1.2 meters. And decremental and dimension increment along global X. If you want to increase the dimension in a particular way, you can give that value as well. If you want to, let's say, if STAAD Foundation finds that 1.5 meter is not applicable, then if you want it to go to 1.6 directly, then you can give 100 mm increment like that. You can give that value. You can specify the value as well. Thickness increment also, if 500 is not enough, then if you want to go for 550, or if you want to go directly to 600, you can give 100 thickness increment here. So I'll not change any of these values here. Then we'll go to sliding and overturning. Here we will show the coefficient of friction, safety against sliding, safety against overturning. We show here. There was nothing you have to change. I'll change the coefficient of friction as 0.4 here, and then you click design. Here you can save the model in different folder, and then you can design. So what it will do is according to the load. So according to the load coming in one node, it will design the foundation. It will check the bearing pressure coming at that foundation corners, and it will iterate this process until it finds that foundation size for that particular node is safe with in bearing, overturning, sliding, everything. And it will do the same process for all nodes. So let's wait for this to run. So you can see the foundation, it has completed the calculations. So depending on the number of nodes and everything, it will take time. So one time for me, it took around 2 hours to finish one foundation design, like a complete foundation design. You can design all these isolated footings in one go. And like if you are going for any warehouse design or something, you can directly take it to STAAD Foundation and it will design all the foundations in just one go. It will take time, but it will design everything. So here you can see it will show calculation sheets, then GA drawing, detailed schedule drawing. So if you go to GA drawing, you can see how the foundations will be placed. So here you can see in these 2 points, we have a combined footing here. So we will have to make it combined. So now I will show you how to do design using that set dimension design type. So here the maximum size coming at these 4 nodes will be F15, Fi50, Fi6, Fi2, Fi1, Fi1, Fi2, then Fi6, Fi5. Okay, so here the maximum foundation size will be 2.9 by 2.9 by 0.5. So let's do one thing. Let's see what happens if I give 2.2 by 2.2 and 0.5 as a foundation size, and I'll set it and then see what the design will, what happens to the design. So I'll set this dimension as 2.2. 2.2 and 500 and then I'll design this. See, you can see that there are a number of errors. If you go up, so STAAD Foundation doesn't have any command file or anything for you to like work on. You'll have to use this space to understand what's the error actually. So it will show everything here only. There will not be any command file or anything. So if you have to manually give, if you have to make load combinations, you will have to manually add it. There is no command file here. So here you can see there is an error. Maximum corner pressure 0.091, bearing capacity 0.154. So the length and the width we have given is not sufficient for the foundation size. So what it will do is we'll check which all nodes satisfy this size requirement. Which all nodes will satisfy the bearing pressure check, then sliding check, overturning moment check, all these checks. Which all nodes will satisfy this? It will give that value. It will give those details. All others that fail will not be shown in GA drawing. So if you when you finish this analysis, you should first go to GA drawing and see if all nodes are passing or not. So I'll change the footing size to 2.9 by 2.9. So this is the maximum size we got for the isolated footings. So I'll give these details and then check. So you can see here, so footing has failed, concrete design maximum limits on foundation and footing dimensions have been reached. So, like I said, we'll check all, we'll do all the design checks, bearing pressure check, then sliding check, overturning moment check, then we have bunching shear failure check, and then one-way shear failure check, then moment check. I mean, we'll check. We usually do checking for the minimum depth of the minimum thickness of the footing based on the moments, right? So we will do all these check, and then if any of the foundation sizes um, does not pass any of this failure, it will show this. So if you set the dimensions, this will happen. So you can go to GA drawing, and here you can see at this point, at these two node locations, you can't see a foundation GA drawing because it's failed, because that part has failed the design. So now you can go to calculation sheet. Here in this calculation sheet, it will give you all the details. So here you can see the footing number, footing length, width, thickness, then what's the reinforcement, reinforcement at the bottom and the reinforcement at the top. Now all these things are calculated by STAAD. Now, if you want to have top reinforcement, if you really want to give a top reinforcement, what you can do is you can go to home, go to global settings, then go to, so there is rigid foundation settings. In this foundation, it shows for top reinforcement setting, there are two options. Either you can give, if you give the second option, what it will do is, will only give a top reinforcements if it encounters any uplift in the foundation part. If you give always calculate top reinforcement based on concrete and soil weight, it will always give you top reinforcements. No matter what type of foundation you choose, it will give you this. If you give the second option, will only calculate the top reinforcement if there is any uplift. So here, this will also give pedestal reinforcement. This now usually it's not that accurate. So then just leave it here. So it will show you the elevations and then plan of the footing. Here is a pedestal size we have provided 600 by 600, and the foundation size will be 2.9 by 2.9. And here you can see 2.5 meter will be the pedestal height from the top of the slab, foundation slab. And then there will be 300 mm increment, 300 mm projection from NGL to the top. So here we will show all the input values that he have provided for the footings, footing geometry, column dimensions, pedestals, then design parameters that you have provided, soil properties, concrete rebars, and sliding overturning, and it will also show global settings. Here, this is what I said, top reinforcement option. So it will calculate top reinforcement only if the foundation is subjected to uplift forces. Now, foundation design option will be net pressure. I have told you before what net pressure is. It will be gross capacity minus the weight of the soil on top of the slab. So that will be net pressure. So I will show you. I'll explain it again later. Now it will give you. It will show all the load combinations that you have given, all the multipliers, everything here. Then apply loads on top of the pedestal. Then so you can see here. So the initial length. So whatever minimum length and width you have provided, it will consider that as the first iteration, first size for the iteration. So it will check the area and it will check the minimum area requirement and then see if it's safe or not. So the final footing size will be here. So if you don't set the design, if you don't set the dimensions, so it will consider 2 meter here and then check if this is safe or not, which is not here. So the minimum area requirement is 4.58 meters. the size, initial size that it will consider will be only 4 meter square. So it will not be safe here. So STAAD Foundation will automatically check the sizes and then arrive at the final footing size. So you can see here all the areas, everything, which load case is it governing. It will show all these. Then depth is governed by ultimate load case. So it will also check with the ultimate load cases also, which we will show here. Now final pedestal height, soil height, everything will calculate all the details, and then it will calculate the net pressures at all corners. Will calculate all the net pressures at all corners of the footing. So here you can see, and then details of out of contact area, governing load case not applicable. There is no area out of contact area here. I will check sliding and overturning as well. So here you can see. If you go here, it will show you the critical load cases, so which govern the overturning and sliding factor of safety. So we'll show all the details in all directions. In X, Y, then resultant directions, it will give you all the details for it. Then top reinforcement design requirements. Since we have given an option where we choose not to design top reinforcement, if there are no uplift, we will not design anything. We will not give any top reinforcement details here. I will check the gross pressures here. Yeah. So we'll check the bearing capacity, bearing pressure against the ultimate load cases as well, with gross bearing capacity. Here, since we have given a net bearing capacity, what it will do is it will add the soil backfill weight and then get the gross bearing capacity, and it will check the gross bearing. It will check the footing sizes with gross bearing capacity of the soil. But what I meant is we gave net bearing capacity, so it will add the backfill soil weight as well, and then find the gross bearing capacity. And with the gross bearing capacity, it will cross check the sizes. And for ultimate load cases also, it will cross check the sizes. And then you can see here the minimum required, the contact area required for ultimate load case is here. And we'll check if the area we have provided, STAAD Foundation has provided is okay or not. Then we'll go to moment calculations. So we'll check the depth required for the moment, critical load case 101, FAT depth, and we'll check the moments, everything. Here, then one-way shear. It will check one-way shear for the critical load case in both directions, in both X and Z directions. Punching shear here. It will check punching shear also. So now we come here. We can see the reinforcement calculations. So for both X and Z direction, it will calculate the reinforcements and then show the like a plan as well. We'll show the plans here, and then we'll give you the spacing for the reinforcement as well. So yes, pedestal reinforcement, I don't usually recommend using this. If you feel free, you can use this. Usually I don't use this pedestal reinforcement provided by STAAD Foundation. Okay. So this is the calculation sheet. So it will provide all the detailed calculations for the foundation design. So this is for one foundation. This is only for one, the foundation calculation for one node number 1. So here in this part, you can see for different nodes, you can check the calculations here, or you can see the summary sheet also. Here it will show you all the footing numbers corresponding to the node numbers, and then it will show you all the length, width, everything here. Also, we'll show the bottom and top reinforcements for the footings as well. Here, if you want to just go through the just see if the foundations are safe, you can either go to GA drawing or you can go to this small tab here below. Here we will show the design summary as well. So here you can see the foundations for two nodes are failed here. So if you just want to know the status, you can just go to this tab and then see for yourself, like if there is any failure or anything. Do you have any doubts in this? Yes, ma'am.
Ram, for combined footing, where did you show that you need a combined footing there?
Yeah, so like if you go to GA drawing, you can see here, right? So two footings are overlapping here. That means we will have to provide combined footing. Otherwise, if it's overlapping, it means isolated footing. The sizes coming for isolated footing is much higher. So you will have to go for combined footing. That's why I have said, okay, we have to go for combined footing here. We can see here, like two foundations are overlapping here. Is this the question you asked?
Yeah, but in STAAD itself, it would make it as a combined footing and give, or we have to mention somewhere?
We have to give, like, yeah.
Okay.
So here I have created a job setup, no? So in the job setup, you will have to give as combined footing job and then design combined footing, which I will come later. I just finished isolated footings. If you in this,
Around.
yes, yes.
So for eccentric, you have to go to footing geometry, and that offset we have to give for eccentric footings.
No, that's where STAAD Foundation becomes a little difficult to work with. If you can give eccentric footings here. Now I'll show this here, like 1 second. We can go to footing geometry and then give offset distances here. So let's give some offset. Let's give 500 mm offset, for example, 500 mm offset here, and then design in both X and Y direction. So we will give a offset of 500 mm in Z direction. So, and then we will design this. Okay, let's go to GA drawing. So you can see here, like it's taking more time because of the eccentric footing. So see, we have given a eccentricity of 500 mm in Z direction. So if you go to GA drawing, you will not find it. Okay, so if you go here, what it will do is it will set the eccentricity for all foundations. So you can't give eccentricity for a particular footing and then design it. If you are giving eccentricity, it will consider the eccentricity applied to all footings. So that's where STAAD has what I find. This is what I found as a disadvantage in STAAD. One of the disadvantages using STAAD foundations. So if you give eccentricity, if the eccentricities that you have provided is applicable to all the foundations that you have considered, then you can provide this. Otherwise, it's best not to use STAAD foundation, or you can save as, and then just consider the footings where the eccentricity will be same. Consider if you have a warehouse where there are multiple number of nodes, and some nodes will have the same eccentricity, then you just select those nodes, design it in STAAD foundation, and then so you repeat this process. This is what you can do if you want a eccentric footing. Okay, so Priya has a doubt. Why we have given this? What's the point of giving this multiplier on soil bearing capacity for ultimate loads? So as I said before, if you don't give this, if you don't change this net bearing capacity, if you don't change the settings, it will consider gross bearing capacity. What we have given is net bearing capacity of the soil, which does not include the soil backfill weight as well. So what happens is there are a lot of other geotechnical parameters in this, so I will not go that much. So if you don't provide net bearing capacity as the input, you will have to, if you give gross bearing capacity, you will have to give a multiplier. Let's say if your gross bearing net bearing capacity is 100 and your gross bearing capacity will be around 150. So you will have to provide multiplier as 1.5. So this is why you are using multiplier here. It depends on all these like global settings. It can also be used, let's say when you are designing for ultimate, as I said before, you will also check the loads for ultimate load cases as well. So this will also use, like it will also multiply this factor to the bearing pressure, bearing capacity as well, and then check according to that.
Hope you understand the sessions. If you have any comments, please let us know through the comment sections. Thank you.